Today we're going to talk about multiplication using patterns. We're going to focus today on the multiples of 2 and 5. Alright, let's start by looking at the patterns we get when we skip count by 2. I have a number line and a hundreds chart. Let's look at the different patterns. On my number line you can see that I have jumped or skipped by 2 each time. So wherever the arrow comes down or that skip ends, that is what I would say if I were counting by 2s. So you can see it goes 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. The same thing on my hundreds chart. It goes 2, 4, 6, 8, 10, 12, 14 and continues. On the number line and in the hundreds chart, you can see that every time I start at a number, I'm going to go up 2, which is skip counting by 2. I started at 2 and I go up 2. Look at the numbers where it ends on my number line and where I have it in my hundreds chart, and let's start looking at the pattern. What are the things that you're noticing? When you have a multiple of 2, right here are the answers in multiplication problems that have 2 in them. Multiples of 2 are always going to be even numbers, and you can look at these examples and the ones we had on our number line and our hundreds chart, and you'll see that all the multiples are even numbers. You'll also notice that multiples of 2 end in the number 0, 2, 4, 6, or 8. Look at that. Even if it's a double-digit number, it will end in the number 0, 2, 4, 6, or 8. The last thing we need to know about multiples of 2's is each multiple of a 2 is 2 more than the one before, and we saw that on our number line and in our hundreds chart. Now let's take a second and look at our number line and our hundreds chart, but this time we're going to be looking for patterns if we are skip counting by 5. So I have 0, 5, 10, 15, 20, and same thing on my hundreds chart, 5, 10, 15, 20, 25, 30, 35, 40. Just like we did with our 2's, look at the pattern. What do you notice with these numbers? Is there a pattern? There is a pattern. Anything that is a multiple of 5, so there's 5 in the multiplication problem and the answer is a multiple of 5. Each multiple of 5 ends in a 0 or 5. Let's look at that. Is that true? Yes, it is. Each multiple of 5 is 5 more than the one before. 0 is and 5 is 5 more than 0. 10 is 5 more than 5. 15 is 5 more than 10. Let's use the things we have just learned about the patterns of 2 and 5 as multiples. Look at this. Can 25 be a multiple of 2? So can I have a multiplication problem that has a 2 in it and the answer will be 25? Can I have a 25 be a multiple of 5? Well, you should answer in the first question, no. 2 cannot be a multiple of 25 because 25 is not an even number. 25 does not end in a 0, 2, 4, 6, or 8. So 25 cannot be a multiple of 2. Let's look at the next one. Can 25 be a multiple of 5? Does this number end in a 0 or a 5? If you answer yes, then it can be a multiple of 5. This one is true. 25 can be a multiple of 5. Let's look at the next one. Can 20 be a multiple of 2? Well, let's look at it. Is 20 an even number? Yes. Does 20 end in 0, 2, 4, 6, or 8? Yes. So can 20 be a multiple of 2? The answer is yes. 20 can be a multiple of 2. Let's look at the next one. Can 20 be a multiple of 5? Well, let's look. Does 20 have a 0 or a 5 as the last number? Yes, it does. Then 20 can be a multiple of 5. Looking at those patterns helped us identify which numbers can be the answers, the products, or in a multiple of 5 problem. All right, let's apply our skip counting to actually solve our multiplication facts. You will see right here I have 2 groups of 6, or 2 times 6. I have drawn a picture of what 2 times 6 would look like in an array. Well, I'm going to group them 2, 4, 6, 8, 10, 12. Did you see how I counted them? 2, 4, 6, 8, 10, 12. I can skip count that, and so I know my answer here is going to be 12. Let's skip count by 5s in the next one. The problem is 5 groups of 3, or 5 times 3. I have my array here that represents 5 groups of 3. So I'm going to circle my groups of 5. That's a group of 5, and a group of 5, and a group of 5, and now I can skip count. 5, 10, 15. I have just solved these multiplication facts by using skip counting. Now it's your turn. Let's use what we know about 2s and 5s and the multiples of their problems to solve these next problems as a class.